Okay, so for our class today, we will continue to talk about linear sequence, but this time I'm going to introduce you a formula which you can use for a linear sequence. Now let's take a look at this example over here. Now right now I have a sequence, and this is a linear sequence. And how do I know that? It is because the term-to-term rule is the same. All right, or the term-to-term rule, it's plus 3 over here. So that is how I know that this is a linear sequence. Now just a quick reminder, for linear sequence, it must be always either you add or subtract the same number, okay? If it's multiply or divide the same number, that is not a linear sequence, okay? So please remember that. So since this is adding, this is a linear sequence, all right? Now let's think about this. Now let's just say, like I have 1, 2, 3, 4, 5 terms over here, which I can write as term 1, term 2, term 3, term 4, and term 5, So let's just say you are interested to find a term which is more than this. Let's just say, the 10th term, all right? Okay, like if you would like to work out the 10th term, so what will be the number? So of course, the first thing you might think of, so since they are all adding the same number, so I have basically just need to add another 3 for another 5 more times, right? Which will get me to 29, okay? So that's doable. But what if, you are interested to find a term which is very big? Like for example, I want to find the 1000 term, all right? Like in this sequence, when it reaches to the 1000 term, what will be that number, all right? So if you were to just choose to just add 3 along the way until to 1000, we definitely can do that, but that will take up a lot of time, correct? So right here, as a mathematician, okay, you can see this and you might think, is there a faster way or a shorter way for me to reach there? Okay? Because since we are dealing with a linear sequence, there might be a certain pattern over here. So let's see what can we identify. All right? Now for me to show you how do I prove this formula out, let's name some of the things over here. Now for this first term over here, we're gonna call this A, okay? And for the term-to-term rule over here, I'm gonna call this a D, okay? Now why do I call it a D? Is because the D over here stands for difference. And it's true enough, how do I find this 3 is actually the difference between this and this number, right? 5 minus 2, that's a difference that will give me 3. So let's write what we know from here first. So I'm gonna start with this. So let's just say I'm interested to find term 1 that is basically just the first number, which is just A, okay? So if I'm interested to find the number of term 2, okay, all I basically need is the first number that I have, and I have to add one of the difference over here. So I'm gonna write plus D over here, okay? For term 3, all right, this term, I will take the original number, the first number over here, and I'm gonna add 3 both times, or I will add D both times. So I will have 2D over here, okay? So T for term 4 is gonna be again A, and I have to add with 1, 2, 3. Okay, 3D over here. And T5, I believe you should be able to see the pattern now. So there's going to be A plus 4D. Okay, now I believe that is enough for us to, see something from here and whether we can craft our formula or not. Now, of course, like over here, I can do this infinitely, all right? And then you will always see like it's going to be A plus, like the next one should be 5D, and then the following one should be A plus 6D, and so on. So we want to see what is the pattern we see here. So let's just say dot, 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 I will want to find the n term, all right? Like this n can be any term I want. It can be 2, 4, and so on. So I know that I will always take the first number, which is a over here, and how many d's do I have to plus? Okay, now that's the question over here. But let's see what can we see from here. Now let's see a pattern. To find term 1, I have no d's. To find the second term, I have 1d. To find the third term, I have 2d. To find the fourth term, I have 3d. And to find the fifth term, I have 4d. Do you notice that the number of d over here, it's always 1 less than the term? All right, let's take a look again. It's 1 less than the term. It's 1 less than the term. 4d, it's 1 less than the term. Correct or not? So there's a pattern over here we see, which we can construct in our formula. We found out that the number of d is always 1 less from the term that we're interested in. So we can write over here, it's always n minus 1. All right, it's always 1 less of the term that we're interested in. Of what? Of the d. Okay, so what you are looking at right now over here will be the formula that we will be using in linear sequence. Now I repeat, it's only going to be used in linear sequence only. Okay, this formula is only applicable for linear sequence. Alright, so what's going to happen right now? Now how do we use this formula? I will describe in a while in examples over here. But let us write down what does all this mean first. So what is a again? A over here is always the first number. First number of the sequence. Okay? Okay? The n over here, alright? The n over here is always referring to the term. Alright, to the term, whichever term you are interested in. And the d over here is referring to the difference. Alright, or we can also say the d over here will be the term to term rule. Okay? Alright, so that's basically it. So that's how we prove this formula over here. Now, having known this, what will be the benefit? Alright, having known this. So again, let's come back to this question here. Alright, like how I get 29, it's I kept adding till I get 29, right? So by knowing this, you have unlocked, the shortcut for you to reach any term you want, like the 10 term or the 100 or the 1000 term. Okay, now let's prove that this is correct. I'm gonna just do over here on this side. Okay, so let's say, all right, I will prove to you that the 10th term of this is 29. So I will always have t to the 10th term that what I'm interested in. All I need to do is to use the formula. So let me write down the formula first. So Tn a plus n minus 1 d. Okay, so since I'm interested to find the 10th term, the first number of the term, that's 2. Okay, and since I'm interested in 10 terms, so that will give me 10 minus 1, and the term to term rule, that's 3. Okay, and then we can further simplify this. That will be 2 plus, that's 9, 9 times 3, all right, that's 27, and true enough, 2 plus 27, that will give you 29. See, all you need to do is to use this formula that we have crafted out to find for any term you want. So back to my second question, like what if you are interested to know what is the 100th term? All right, you do not have to add until you reach the 100th term. You can just very quickly use the formula over here. So again, I'm going to show you the term that we're interested in is the 100th term. So A is my 2 plus 100 minus 1, and my term to term rule, that's going to be 3. Okay, well, let me change this to blue in color. Okay, so when we solve this, we will have 2. I will have over here 299 times 3. Okay, 200, sorry, not 200, 99 times 3. That will give me plus 297. And my final answer for this term is going to be 299. Okay, so that's how we find it. We can go this even further. We can do this like for the 1,000 term and whatnot, depends on which you are interested in over here. Okay, all right, so over here the next one. All right, so when we have a linear sequence, like in these two examples here, both of them are linear sequence. Like how do I know? Because they have the same term to term rule. In this case, it's plus 3 all the way. So in question, you might see the question is asking you, they want you to construct the n-term rule to represent this sequence. All right. The n-term rule over here is the expression that represents this sequence. Okay. So how do we find the n-term rule? It's we're going to use this formula again. All right. So what we're going to do is, since we are not interested to finding in any term yet, we just want to form an expression. So we are not needed to substitute the n over here. So what am I going to do over here is just this. So I'm going to write down the formula first. So that's going to be a plus n minus 1 d. Okay? So all you need to do is to substitute the relevant information inside. So my a over here, that's 2 plus n minus 1, because we just want to form an expression just to see the expression that represents the sequence. My term to term rule, it's 3. Okay, so all you need to do now is expand. So what do I get? I will get 2, and then I will get here plus 3n, and this one I will get minus 3. And so my final expression will look like this. It will be 3n minus 1. Okay, so what you are seeing right now over here, that is the expression that represent the linear sequence. Okay, the linear sequence above. Okay, all right. So what does this mean? This expression over here is basically like the key to unlock any term you want in this sequence, like what we do over here. So it's the same thing. This and this is basically the same thing, but you are just forming an expression over here. So like again, if you are interested to find the 10 term over here, we can see we'll get the same thing. The 10 term, which n is equals to 10, right? So 3 times 10, that's 30. 30 minus 1, and true enough, that's 29. Okay? And the 100 term is true as well. 100, 3 times 100, that's 300. 300 minus 1, that's 299. Can you see that? It's the same thing over here. Okay? So next example, it's the same thing. If I want you to construct the n-term rule, all right? So first, you need to identify what is this sequence first, okay? Because remember, this formula can only be used for a linear sequence. So in this case, the term-to-term rule, or is minus 2. Okay, so I'm going to use the formula now. Since we already know this is a linear sequence, so I can use this formula. So a plus n minus 1 d. So I will substitute now the relevant information. My first term, that is 6. Since I want to make a sequence, so this is going to be n minus 1. And my term-to-term rule, that's going to be minus 2. Okay? Now let's expand this over here, see what's going to happen. So what do I have over here? I have 6, okay? Now this one, you have to be careful. Positive and negative, all right? Okay? Positive and negative over here, that will give you negative 2n, okay? And then over here, positive and negative, but then don't forget inside here. Now for those of you who are confused, right? I will suggest you to do this slowly. Okay, instead I think I will do it like this. For those who are still confused with this, plus is going to be plus, let's keep that. Now we will just expand from here, okay? 2 times n, remember to put back your bracket. So that's going to be negative 2n, all right? And then I have negative 2 times negative 1, that will give me negative 1. Sorry, positive 1. Okay? So right now, then you open up the bracket again, okay? So I will get 6 right now. I will have minus 2n plus 1, okay? So if I would like to, sorry, what am I doing? This is supposed to be 2, my apologies. So this is supposed to be 2, okay? So now we solve this, so what do I get right now? So I will have 8 over here, minus 2n. So that is my expression over here to represent the sequence. Now again, algebra, it's very interesting over here because the moment we find our expression, like if you happen to doubt, is this correct or not, we can always, we can always just quickly substitute one of the term over here to check if this is correct. For example, let's just say, I want to find this one. This is basically term 4, right? 1, 2, 3, 4. So if n I substitute with 4, 2 times 4, that's going to be 8. 8 minus 8, and throw it out, that's going to be 0. And if you're still not happy with it, you can feel free to check with other terms, all right? You can, like example, this one, the first one. N is equals to 1. 2 times 1, that's 2. 8 minus 2, that's 6. So we know that your expression is correct. Okay? So again, when we deal with linear sequence, always remember this formula over here, because this formula will help you to find any term you want from that sequence. Doesn't matter, it's from hundreds, thousands, or millions. Okay? And it can also help you to construct the expression which represents the sequence. And this expression here can unlock any numbers you want from the linear sequence. Okay? That's all. Thank you.